Who wants to start us off? What one caused you havoc? Which one didn't you like on any of the pages? This first page? Yeah, Sanborn. What page?
30 and 33.
Oh, it's just number 30 and what?
30 and 33. I think it's like
30 and 30 from the same group right there? Is that it right up here? Logical reasoning? Okay, so let's sketch this out. Pause it for a sec. I think so. I think I labeled everything correctly. So let's keep going here. Now it says we want to do 30. Find angle BAD.
So that'd be 60.
How do you know?
Wait, 60.
Measure of what? What? Angle what?
EAC
Hold on. EAC is? Yep.
it's divided into two parts.
How do you know it's divided into two parts? But, oh, it's bisected, isn't it?
Yeah.
So we have to write that down. Angle equals 2 times what? The measure of angle what? We angle EAC is twice which angle? FAC or EAF? Sure, it doesn't matter actually, does it? EAF. So what does that mean? We know that angle EAC is what? So no, that's 100 degrees, 2 times the angle EAF, because it bisects it, right? So the measure of angle EAF is what? 50 degrees. So you know that this right here is 50 degrees, so therefore what does BAD have to be?
50 degrees.
50 degrees. Is that right? Yeah. Yeah.
When I was doing it,
Oh, did I do it wrong?
well, no. But when I was doing it, I read it to be.
Oh, there's a problem.
Yeah. It doesn't.
There is a big problem here. What's the problem?
It's more than 100.
Yeah, let's look at it. If that was 50, right? The whole angle here is 130 degrees, right? So what's the problem? 50 plus 50 plus 50 is bigger than 100 degrees. Huh. So is my drawing wrong?
No.
Okay, let's pause and try to figure out what we did wrong here. Are all these 6 things still true right here? Yeah, they are. We know that EAC is twice EAF because it's twice that one angle. So we know that this still is 50 degrees, and this is 50 degrees. So BAD is going to be 50 degrees. Can you tell me what this angle is? What is angle? Just a side question. What's DAE going to be? Can someone tell me what this angle is right here? What's DAE going to be? What do you think it's going to be?
110.
Why do you think it's 110?
Because 360 minus 130 is 260. Minus 150.
Yeah, how many angles do we have here? We have 130. And how many 50-degree angles do we have? We have 3 50-degree angles plus angle DAE. Sorry, DAE has to be what? Have we just gone all the way around the circle? We've gone all the way around the circle, so it has to be 360. So angle DAE is going to be 230 minus 150, which is what? What? 80 degrees. That's not what it's asking, but we could put that in there. Now it's asking for 33, which is find angle FAD. What's FAD going to be? Oh, did we just find out what we needed? Yeah, FAD is going to be what?
80 plus 50.
80 plus 50 is?
130.
130 degrees, yeah. So is this drawing to scale? No, it's not. Could you use a protractor and make it to scale? Sure, if you wanted to. Absolutely. We good? Does that answer your question? Go ahead, Luke. Angle into 2 adjacent angles that are congruent. So if I gave you an angle BAC and I asked you to draw the angle bisector, you will be drawing what? You'll be drawing a, what's it called? No, not a line.
Array.
Array. It's right there in front of you. You're drawing a ray.
A to in between B and C.
Exactly. Such that this angle and this angle are congruent. The angles are congruent. So you know that angle BAD is congruent to which angle? DAC. Exactly. And the angle bisector is this ray, not AD. That is the angle bisector. Are we okay with that?
Mm-hmm.
I'll use a complete sentence. Is the angle bisector. Okay, that's great. So the big question is, using a straight edge and a pencil, can you just draw any angle you want? Sure. Let's draw this angle right here. B, again, A, C. Using just a compass and a straight edge, and I'm going to give you these things right now, how would you go about drawing the angle bisector? I'm going to give them to you right now, and you're going to do it out, okay? So step 2 is draw 2 arcs. Draw 1 arc at E with radius at least what? Yeah, with radius r, it has to be greater than 1/2 dE, but it has to be less than what? Actually, less than anything you want. It just your intersection point might be out here, but it just has to be greater than halfway, because if you don't go halfway, what's not going to happen? It won't intersect. So then you draw 1 arc at E and another at what? At D with the same radius.
Mr. Seamon,
Yes.
if you draw a full circle at D and E,
Yes.
you can make sure that you're correct, because where the circle intersects, it should go through
Yeah.
point A.
Yes. Oh, sure. So you could just take the same distance and draw the full circle? Sure. So then you draw 1 arc here and 1 arc there, and then you've got these 2 points.
Where'd you get those arcs?
I picked a distance. I picked a radius. You see this radius right here?
Mhm.
That radius is greater than half the distance from D to E, and I just drew the 2 arcs, and you end up with the angle bisector. Why is that the angle bisector? Well, you can prove there's a lot of congruent triangles here. Let's call that point Q. You can prove that triangle AQC is congruent to triangle what? AQB. And if that's the case, if those 2 triangles are congruent, this angle is congruent to that angle. So it has to be the angle bisector. Okay, let's move on a little bit here. What about the midpoint of a segment? If I gave you, let's just logic this out. If I gave you a segment, I drew a segment like this, A to B. What's an easy way to find the midpoint? I'll make it smaller so we can make it work for it. We're dividing it in 2, so you can't fold the screen. We're not folding anything. Why are you doing it? Come on. Let's go. Come on. Okay, fine. You don't want to work. Well, you draw 1 arc and at A with radius r, and then what do you do at B? You do the same thing. If you do that same arc, what do you know about this distance? Let's call that Q, and this distance. They're both r. So AQ is equal to BQ. You know that this distance, right, that's going to be the same side, right angle. So what can you prove? Triangle. You can prove that triangle A, let's call that what, point Z right there. AZQ is congruent to what? BZQ. So therefore, AZ has to be congruent to BZ. So have we bisected a side? So bisecting a side is pretty straightforward. You just draw 1 arc, and then you just draw another arc.
Does
Yep.
it matter, like, how big the arc is?
They have to be at least halfway across, because if it's not halfway across, are they going to touch?
So you approximate?
You approximate, like you say, okay, don't go all the way to B,
Right.
and don't go less than half. So you approximate. So yes, there's a little approximation here, but does it matter how big it is as long as it's between half and the full distance? No. So R has to be. Actually, could R be greater than the distance?
Yes, it could. It's just you're gonna
Be
have a big
way
line.
out, right? So as long as R is greater than 1/2 AB, you are all set. You can go a million miles, right? Your 2 points are just going to be really far away. If you connect them, will it bisect the line? It'll still bisect the line, absolutely, yeah. Okay. Okay, so that's just what we did there. A few more pieces of terminology. 2 angles are vertical angles if their sides form pairs of opposite rays. two adjacent angles are a linear pair if their non-common sides are opposite rays. First of all, what's an opposite ray? Well, what's a ray?
Point with a line.
Point with a line coming off of it. So what's an opposite ray? Opposite directions.
So straight line.
Together they form a straight line. So if that's A and this is B and this is C, AB is a ray and it's opposite to AC. Exactly.
So they're vertically angled.
So two angles are vertical angles if their sides form common pairs of opposite rays. Common pairs of opposite rays. So let's just think about this real carefully.